Yeah, I'm just going to do this question. It's proving the sum of the two segments that are equal to the length of the other, right? So this is going to be the diagram we're going to use. I'm going to just say quickly, we're going to prove CG plus BE equals AF. You'll see the maths later on. Just note this triangle. Few things to note is the information we're given. We're given that the A, B, C, D, and E, D, F, G are identical and they both share the point D. So this is practically, so these two are the same square. So here's the thing. We're going to make some proofs. DC equals CG because they're the same lines from the same square. Therefore, DCG is an isosceles triangle. We're then going to denote DCG as X. We're going to say that DGC is also X. That's practically like these two angles here. Sorry. Then we're going to just ACD equals FGD equals 90 degrees. Then we can just say ACD equals FGD equals 90 plus x. So basically we're talking about these angles. Then we can isolate this thing and we can isolate the values that we know to figure out to basically figure out and see, and we'll get a parallelogram, not a parallelogram, a trapezium. Sorry, a trapezium. Basically this is the trapezium. We can then also deduce the few more angles. CAF equals GFF equals 90 minus x. That is because of the bottom of this parallelogram. Then we have CAF plus ACG equals 180 degrees. Therefore, CG is parallel to AF. Angles EFG equals BAC equals 90 degrees. CFF plus BAF equals BAC. 90 minus x equals plus angles BFF equals 90 degrees. Therefore, BFF equals x. We can then solve these ones. Angles that GFFE plus AFE equals EFG. We then solve and get AFF equals x. Now let's draw lines practically perpendicular. It's the same diagram, but now we're going to draw lines that are perpendicular to the point, right? Then we can easily prove similarity of these points. We're going to prove BAJ, EIF, and TDG. We then say, how to do this? We first equate the angles because we all know that they equal x. We equate the angles that we know equal 90 degrees. We also equate the lines because, well, it's the same square. These are both identical squares, right? We then are going to get that these are the same triangle. Therefore, in terms of length, these are the lengths that we have. AJ equals CH, IF equals HG. Then we can use some maths saying CG equals CH plus HJ, meaning CG H equals HG plus IE. Practically, this is basically saying this line equals this line and this line equals this line. So we found this portion. So we need JI and B. How are we going to prove that? Well, that's going to be very, very simple, right? Well, what we're going to do is isolate this. We're going to isolate the top part, right? Then we practically have that this is x and we have that these are the two same sides and we know that this is 90 degrees. We can then use that to practically prove that EI equals BJ, right? Because we need to prove that the lengths are the same. How? We're going to first prove that that the triangles are BAG and EFF is the same square, proven. Then through side angle, we then through side angle, we then get that BJI is equal to EIF. Therefore, BJ is equal to EI, and we also have BJI equals AIJ equals 90 degrees. So it's safe to assume that BGEI is a rectangle, meaning BE equals JI. Then we have the finishing touches. This is the finishing touches. And yeah, then we add the two. We have we have one equation, we have the second equation, we add the two, we get that BE plus CG equals AJ, JI, IF, that's AF. That means that, yeah, we've proven that this line is equal to the sum of these two lines.